Hi guys, so we look at the new topic, and our new topic is under distance, time and speed time graph. So we have distance time graph and also speed time graph. So in this video we are looking at distance time graphs. So distance time graphs are defined as graphs which show the distance moved by an object with time. The distance moved by an object with time. So these are graphs. We are talking about the graphs which shows the distance moved by an object with time. So these graphs, they normally form a gradient. So when you're looking at the distance time graph, when you have a gradient, we are talking about the steepness of the graph itself. So we have, if you have a line like this, the steepness of this line is what we call the gradient. So we can calculate the gradient by having the coordinates here at this point and also the coordinates at that point when we go to coordinate geometry. So you can find the gradient of this line. So this is what we have. So we are told that the gradient gives the rate of change in distance. So the gradient of the distance or of the graph for the distance time graph, it shows or it gives the rate of change in distance. When we talk of the rate of change in distance, that is what we mean by saying the speed. So speed is the rate of change of distance. It is the rate of change of distance. So that is what speed is all about. Now, we have a question or the formula for the speed. So we are calculating the speed. We say speed is the change in distance with time. The change in distance with time. So this means that when you're calculating the speed, you say speed is equal to distance covered, the distance which you cover from one point to another, okay, divided by the time taken when you covered that distance, either by walking, by cycling, by driving. So that is what speed is all about. So I have also brought this issue here. I want to believe at a certain point in our mathematics life, in the previous grades, it could be the previous grades, also in our I can just say previous grades, we came across this, even in different subjects. It could be physics. We came across this. The S stands for speed, the D stands for distance, and also the T stands for time taken. So this is what we have. So speed is equal to distance over time taken. The question may also come to say, find the time when you have been given the speed the distance covered and also the speed for that distance which has been covered. So you can say time is equal to distance over speed. The D is always on top when you are looking for speed or when you are looking for time. The speed is always, the distance is always the denominator, the speed is the numerator, or the time is the numerator. So this is what we have. So the question may come also to say, find the distance if the speed and time is known. So you find the distance by distance is equal to, since both the speed and the time are the denominators, it means that you multiply the two. So distance is equal to speed multiplied by time. if you have been given the speed and also the time taken. What do we have now? Now, this is the formula. Now we have the example which has been given there. The example is the graph below, this graph here, meaning this line here, from 0 here up to where it has reached, shows the distance of an object. This is the graph, not these lines, not these lines, no. These are just showing us where the graph was reached to where y-axis is concerned. And also this other line, it shows us where the graph was reached, okay, or the value of x to this graph here along the x-axis. And this line also shows us the value of y along y-axis. So this is what we have. Now the question is, the graph below shows the distance of an object over a time. The time is 5s, which is 5 seconds. Now, the question is, find the speed. You find the speed. So using the formula we have been given there, or the formula which is supposed to be used is speed is equal to distance over time taken. So we are going to say speed is equal to our distance. It is always represented by the y-axis. So distance is always represented by the y-axis, and the time is always represented by the x-axis. So when we go to this speed time graph, we'll also look at the graph for speed. As of now, looking at the graph for distance, we are going to discover that if instead of using distance, now we are going to use the speed this side, or velocity, because speed and velocity means the same thing. So we are going to discover that instead of using speed here, we are going to use, instead of using distance, we are going to use the speed. And the units, instead of having m, which is meters, we are going to have m/s, which is meters per second, because the speed, the units for speed is always in meters per second. But the units for distance, it can be meters or it can be kilometers, etc. If I told there are other units which we can use when we are measuring an object or the length of something in or the distance of something in those units which are used to find the distance. So in this case, we're saying speed is equal to distance. The distance covered is 80. We'll say 80 meters over time taken is 5 seconds. So our final answer will be speed is equal to, now we'll divide 5 into 80. How many times does 5 go into 80? Questions like this in the exam, sometimes you have issues to find to know how many times 5 can go into 80. You don't have a calculator. This is paper 1. By the way, this is paper 1 questions, which always comes at the end of the same paper, paper 1. So what we do now, this one into this, I will say 5 into 8, it goes 1. Remainder 3. 5 into 30, it goes 16. So it will be 16 meters over s. The s is for the seconds. So the speed of this graph there is 16 meters per second. Thank you so much.